Welcome back. In this lesson, we're going to look at the formation of a cloud. So a cloud is a mass of air that has enough water in it that it is essentially full, that air is as full as it can be. It can't hold much more water, and you're able to start seeing actually the liquid water in the air. So when water is a gas, it's invisible. So there's water vapor in the air that you're looking at right now, and you can't see it. You can't see it. It's not like a fog or a cloud. But as warm air that has lots of moisture rises in the atmosphere and cools off, you're going to see that it produces a bigger amount of, it's holding as much as it can. As soon as it reaches the dew point, you're going to be able to see it, and that's a cloud. So let's look at some of the particulars. So how do you make a cloud? You've got to have some air that has water in it. That's the only way to make a cloud. So let's imagine at the surface you have a certain temperature, and that means that you have a certain ability to hold water. So in this example, I've got a temperature of 92 degrees Fahrenheit, so that's a warm summer day, hot summer day. Hot air holds lots and lots of water. Okay, so imagine that a sponge can soak up some water. Well, warm air acts like a sponge and can soak up lots of water. Okay, so as that air is warm, okay, so for instance, the ground during summer is very warm, and so the ground heats the air, and that air now becomes lighter. So it becomes less dense because warm air is less dense than cold air. Cold air sinks, warm air rises. So as it rises, it's carrying the water that it already has. Okay, so it has a big sponge at the surface. Well, as it gets higher in the sky, it doesn't hold as much water because the temperature's getting colder. So mid-altitude, 3,000 feet, the temperature's 76. Well, 76 doesn't hold as much water as 92. A 92-degree air holds much more water. So whatever water is in the air is now higher relative humidity. It's more towards whatever that sponge can hold. Okay? As it continues to rise, the temperature drops. As it drops, the sponge shrinks. Okay? Because the air holds less and less water, but whatever water it has, it's still holding on to. So what will happen is that it eventually goes under the dew point. And the dew point is when water comes out of the gas phase and comes back into liquid. Now you can see it. Suddenly now it's a white cloud. The same amount of water was in the air, but it was invisible at the surface. That same amount of water was in the air at 3,000 feet and still invisible. But as soon as it gets to 6,000 feet, the sponge is so full that it starts condensing into liquid water, and you can see it, and that's what the white clouds are. Atmospheric lifting means that the warm air is rising, and as it rises into cold air. So that warm air with water going up into the cool air allows it to be higher and higher percentage of relative humidity, and so it becomes more and more like a cloud. When it reaches 100% relative humidity, it'll precipitate and start raining. Now, one example of what makes a cloud rise, okay, we already looked at the fact that if you had hot air was going to rise. Well, another way that you can make water in the air rise is by wind blowing it into a mountain. So let's imagine I've got some wind sitting there minding its own business, and that air has moisture in it. So I've got a certain quantity of air that has a certain temperature, and that certain temperature can hold a certain amount of water. So I've got some air with some water in it. Now the wind blows that air. Okay, so the air is moving, and as it's moving, it's carrying the water with it. Let's imagine in this scenario that air is now shoved into a mountain. Well, the mountain is in the way. The wind is blowing the air into the mountain, and the mountain is stopping that air. So what will happen is it starts climbing up the mountain, okay, because the mountain is triangular shaped. So as that wind is driving that air, it will rise. And as it rises, it gets colder because it's colder on the top of a mountain than it is at the valley. So as it gets colder, the sponge shrinks. And as the sponge shrinks, it becomes more and more possible that you're going to be past the dew point. And the dew point is the temperature at which all the water starts condensing back into liquid water, and you can start seeing the cloud. So orthography is the study of mountains. So if you lift a cloud because it runs into a hill and forced to go higher in altitude, and when that happens, it gets colder, and the cold air can hold less water, and so it becomes higher towards 100%. You're going to have a cloud that forms on the one side of the mountain. Normally, what would happen then is once it reaches the dew point, it will start raining, and it will rain on the one side of the hill, and then the cloud goes over, or the remnants of that cloud will go over the top of the hill. Another type of way that you can make it raise is by convergence of two different air masses. So here's an example where I've got cold air and warm air is slamming into that cold air. All right, so cold air sinks, warm air rises. So if cold air meets warm air in a car crash, the cold air stays close to the ground and the warm air actually climbs up, almost like it's a slope, climbs up, and so the warm air will climb up and the cold air will sit down. That air all has water in it. Okay, that warm air from the warm air mass has water in it, and since it's going higher in the atmosphere, it cools off, and as it cools off, that cold air can hold less water. That means the same amount of water is a higher percentage relative humidity. Once it reaches the dew point, you're going to get rain. Okay, so a lot of times what we call a cold front is when cold air slams into warm air. And when that happens, you almost always have thunderstorms. It's usually a summertime thing when you have warm air, but cold air coming down from the north, slamming into warm air that's sitting there. And the warm air shoves up the hill. The cloud forms because as that warm air is going higher in the atmosphere, it's getting colder, more relative humidity.